Rapid Spanning Tree Protocol 802.1w is significantly faster than Spanning Tree Protocol 802.1d. Now, why is that? Well, there's a few different reasons. The big ones being the fact that it doesn't rely on the timers. It doesn't rely on the max age timer or the forward delay timer when ultimately determining whether the tree is loop-free or not. So, does it totally eliminate timers? No. The timers are still there, and they're used for backwards compatibility. So if you have an 802.1d switch plugged into an 802.1w switch, then those timers will come into play there. In addition, there is a proposal and agreement process with Rapid Spanning Tree Protocol, and this proposal and agreement process occurs between the switches so they can ultimately determine whether they have successfully created that loop-free topology in that rapid amount of time. However, if this proposal and agreement process isn't working, well then the Rapid Spanning Tree Protocol switches will rely on the timers, the max age timer and the forward delay timers, to make sure that they have that loop-free topology that they are trying to achieve. But one of the big items which makes Spanning Tree Protocol, Rapid Spanning Tree Protocol faster is the ability to generate topology change BPDUs regardless of whether you're the root bridge or not. With Spanning Tree Protocol, it's only the root bridge that is able to generate these topology change BPDUs as we see right here. Through the use of topology change notifications and the topology change acknowledgements, right, the root bridge is being notified of the change. And then it's up to the root bridge to tell all the other switches about the change. But with the Rapid Spanning Tree Protocol, no. Look at this. We have a failure on switch 4. Let's say that was the root port, and this was originally the blocked port. Well, this failure occurs of the root port, and the blocked port transitions into being the root port. And a topology change BPDU is generated by switch 4, not the root bridge. So it's the switch that is experiencing the failure that's generating this topology change now. So the topology change is sent out, flooded through the network, and as each switch receives it, they will go through the process they need to go through in order to make this transition happen. Now, the transition is going to occur only if that topology change BPDU is going to make these particular switches change. So, for example, if we look at switch 5, originally, if this was the root port, as we said, then this was the designated port, meaning this was a root port, this was designated, this was root, this was designated, this was designated, this was root, this was designated, this was blocked. So in reality here, none of these switches are going to have to make a change. This link failed, this changes, all right, no big deal in our particular example. But what if a change had to occur? What if a switch received this topology change BPDU, and as it runs its algorithm, a root port now has to become a designated port, or one of its block ports has to go into the forwarding state and become a root port? Well, that is possible, and through the propagation of this topology change BPDU, these switches are going to be able to figure out what has to be done on their own to produce that loop-free topology. What else is going to happen with this topology change BPDU? Well, the switch that receives the topology change BPDU inbound, for example, on that interface, switch 2, what it will do is it will now expire every single MAC address in the MAC address table that is not associated with this port right here. So all the other ports on the switch, their MAC addresses in the MAC address table will expire. They will be cleaned out immediately. There's no waiting at all. Clean it out. That way there's no potential for stale entries or inappropriate forwarding of traffic at any point in time. Let's clean it up. Let's clear it out as quickly as possible. And then we'll just relearn the MAC addresses as frames arrive on the interfaces. So it keeps things clean, keeps things tidy. And you might be thinking, ooh, wow, really have to relearn all those MAC addresses? It's not that big of a deal. Our switches can do that relatively efficiently, and it's better to relearn them than to have those stale entries, which could potentially cause issues and the misforwarding of frames within our topology. So what are we dealing with rapid spanning tree protocol? We're dealing with these non-edge ports that are transitioning. That's what it is. This is a non-edge port. This is non-edge, 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 etc., etc. What is an edge port? It is simply a port that is connecting us up to end stations where we do not expect to receive BPDUs. That's what an edge port is. So a non-edge port is every other port in that spanning tree topology. How do we get edge ports? We get edge ports by turning on the port fast feature on an interface. So we're going to turn the port fast feature on those ports that go down to end stations, like a PC or a phone or a printer as an example, or server as well. So those would be edge ports, and then this would be a non-edge port, as we said, and so on and so forth. So when a non-edge port transitions from forwarding to blocking, blocking to forwarding, etc., the topology change is occurring, and the topology change BPDU gets sent out by the switch. Focus on ASW1 here. ASW1, if we look at show spanning tree for VLAN 10, we can see that gigabit 0/1 is the root port, and it is currently in the forwarding state. The root bridge is DSW1. What we want to do is we want to cause a failure to happen to this root port, which means that gigabit 0/2 is going to transition into the root port role. It's going to be in the forwarding state. But in order to notify all the other devices in the topology about this change, ASW1 will send out the topology change BPDU. It's not going to send a topology change notification about this at all, and that's what we want to examine. The TCN and the TCA are gone for rapid spanning tree protocol. Just the topology change BPDU is going to be sent by the switch. So let's examine that. We'll turn on our debug, spanning tree events, and we'll go to interface or global configuration mode, interface gigabit 0/1, and let's now bring down this port. And when we bring down this port, we will see that gigabit 0/2 transitions to a root port and a topology change trap, the topology change BPDU, is sent immediately. And we can see that right here. Gig 02 is now the root port for VLAN 10, and there is the topology change trap, that BPDU that's being sent about this change out gigabit 0/2, and every other switch in the topology will receive it.